Bien, deshabilité la sala de espera. Ahí sí. Hola, buenas tardes.
Hello, good afternoon.
Oh, ok. Ahí sí, estaba en canal de inglés. Buenas tardes. Vamos a esperar
So, good afternoon. We're going to wait a couple minutes while more participants join in.
Bien, siendo las 14:05, damos
Since
inicio.
it is 2:05, we're going to begin this session as part of the interoperability for Latin American and Caribbean. My name is Sonia Espinosa. I'm the leader in the area of interoperability in SENSE, and I participate in PAHO projects. As we have discussed throughout this series of seminars, this is part of a convergency of initiatives, amongst them the LACPASS, the WHO initiative, and on our behalf, the PAHO project DDCC, to generate certificates based on the WHO certificate. In the region, the initiative Convergence is this one right here that you can see up front on the screen. There is a whole series of participating countries. You must have received this invitation bit as a result of previous sessions. If there's someone who does not belong to any of these, you're most welcome to join in. For example, if you're in PAHO and not in LACPASS, you're all welcome. And in that regard, therefore, the LACPASS is the broader project which seeks in trans-border interoperability based on use and the IPS profile. Particularly in these sessions on Thursdays, we're focusing on the generation of DSP. But it is very important that you do understand that this is only part of a component on a much broader context, which is being worked with all of the participating countries. Today, especially, we're going to be presenting information regarding servers based on the HL7 FHIR standard. As you can see up front, this is part of the IPS components, as well as the DDCC components. This comes from a whole series of presentations that we have been making earlier since February. In February, we carried out introductory presentations. During the month of March, now we have been working on more specific issues from DDCC. Today we're convened by the data repository. As I said before, we're trying to show which are the characteristics that must be accomplished by a server based on the HL7 FHIR standard. And at the end of the session, to conduct an installation exercise so that you may see which are the steps to follow. And if you have any doubts, you can, of course, ask questions. The idea of presenting this in a presentation like today's is to support the installation activities as part of the LACPASS project, in the understanding that a server and the data repository goes far beyond this project. Therefore, our presentation today is agnostic, we could say, and we're trying to seek out is to give knowledge and leave a facilitating element for the generation of the DDCC, IPS, as well as any other initiative that you deem interesting and that you can take up with that which we're going to be presenting you today. So, starting today, a whole series of presentations are starting, which are more technical in nature. They're more and more technical every day, especially today with regard to servers. What comes next is to speak about transactions, the DDCC transactions. And there we will be showing you how to assemble the first message, which is the entry message for the generation of a certificate. And we will conclude on April the 13th by a presentation that tackles previous elements to have a good generation of the certificate. As I was telling you, in fact, those participants who are members of countries who do not belong to any of the initiatives that you see up front, and if you would like to join in, we open the invitation for you to join us. To do this, there are several points of contact, Carlos Núñez among them. And I'm sure that many of you know him. We have here his email, and also we have Sonia Espinosa, and you can see my email also up front. Okay, so without further ado, I would like to yield the floor now to Marcelo Cabello, who will be speaking about the repository and the servers based on HET7 Fire. Welcome, Marcelo. Thank you, Sonia. So, very good afternoon, everyone. My name is Marcelo Cabello. I'm an engineer in informatics. I work in the area of medical issues for many years now. I have gone through different areas in the actual development of clinical documents, as well as several developments with regard to lab systems. Lately, since I'm here with SENS, I've been working on syntactic standards between HL7 Fire, and for 2 years now as well, we've been working fully in semantic standards. So I have been self-baptized myself as a specialist in clinical terminology. Okay, today's presentation is quite light. And basically what we will be discussing is a description of the servers based on the Fire specification and some of the basic characteristics which are required for the implementation. And as Sonia was telling us, this is an exercise which is being carried out as to how to install a server for general purposes. Very well then, first to let you know that generally speaking, the Fire servers and in the implementations we've seen earlier, these can, of course, include a full or a partial implementation of all the specifications in the standard. On the other hand, also, each and every version deals with specific characteristics. And also, behind this, we have the elements of this that is supporting all these specs, starting with DSP 12, and then as a draft, And later on, this is on USB 3. And nowadays, we are here in the R4, and we are coming out with the projects plus the implementation and specifications of NR5. These are the ones that indeed contain adjustments to specifications in the resource models so that they may be better adjusted. In keeping with the recommendations made by the community, and of course, the experts who look into the availability of these resources and specs in keeping with the situations which are faced in the real world. In actuality, servers do have a capability to bring in new functionality, elements which have not yet been fully defined in the standard. As we have heard in previous talks, the standard covers the rule of 80-20. In other words, it covers 80% of the cases of utilization, generally speaking, and those elements which are more specific in keeping with special realities are then extended in the standard, and then we go to the complete, to the standard of complete utilization, complete use. The FHIR servers in general, their basic functions may be seen on these dots here. One is the operations CRUD. Let me recall the FHIR specification is based on an architectonic style, which is resin. And in order to interact with an APIC which is based on a RESP, you must use
para hacer las interacciones
to conduct the interactions vis-a-vis the contents of the server. And all of these verbs operate with regard with certain elements which are known as resources. On the other hand, those operations have to do with the fact of creating elements, updating them, or deleting them. These servers must also meet certain requirements of versioning. In other words, to the extent that you modify the resources, new versions of them appear. It also contemplates the validation of same. In other words, it has syntactic tools that allow for the validation of the structures and the resources so that these may be kept in the format required in the server with the adequate use. And also these servers provide the capability for transactions. Although they're not implemented 100%, indeed they have a very high rate of compliance as to those things which are implemented in the server. In the case of transactions, correction, as regards as transactions, this is the support that the servers have in order to execute more complex taxes, such as batch position or transactional positioning. In other words, changing many things in a server. And if there is any failure, we carry out the rollback. And then the transaction is not confirmed. If everything is in order, however, we can confirm everything. As regards the actual operations, we have the basic operations through, and also other operations which are based upon the RPC. And these are verbs, as we call them, which are names of operations, which carry out some specific activity. They may be more complex. They do not meet with the basic crew operations. And by doing this, we can meet and we can conduct a certain action, as I was saying earlier, which entails more than the mere creation or modification of certain things. They may carry out more refined operations. In the case of the searches, búsquedas in Spanish. It provides a sufficient number of searches of parameters to update the information. However, if the utilization situation requires from a special UKA, then you can extend the server to the so-called CH parameters, with which you can specify searches regarding filters or specific issues. Frequently, many of these things I'm telling you about are reflected on a resource known as capability statement, which is described as a resource that establishes the capabilities of such server, and which might serve also in order to describe the functionality that a server should have in the future. In the case of these historials, as we call them, to have the capability that resources, when they change in their status, let's say a patient resource or any other resource in the specification, and to the extent that time advances, they may undergo changes, and such changes are reflected in this element that we call historical or historial. And I can conduct those operations without any further hindrance. Okay, so the HL7 fire spec is quite extensive. It is basically created in English, but it's quite solid because you may find in it the elements that you may require in order to conduct the implementation. Here on the slide, what we're describing are the operations that must be supported according to the different types. And but to do this, in the case of the resources, we have instructions to conduct a reading of such resources, instance level interactions, the historical nature of those very resources from before, and also other operations such as the update that have to do with the entirety of the resource.
Another instruction, the deleted items are performed logically. They're not physically deleted, but they're simply marked to indicate that the resource is not active. And you could also look at the entire history and retrieve information about all the changes. For example, if there were 3 status changes, you would find them there. Then you can also look at the type level of interactions. You have create, to create new resources, to do searches using filters. And then there's others which are more general. For example, the server capabilities, or also to trigger transactional elements using a batch mechanism, or using change confirmation elements. So all of these operations can be applied at a specific instance, and this would be the format to do that. So you have the base address for the server, the type of resource, and then the resource ID. In the case of other operations, when you're performing a search, you would simply insert the base, the type of resources, and after that, you would list the type of resource or criteria. And if you're working with the general server characteristics, and this is mainly when you're conducting operations or when you're querying the server about its capabilities. Fire servers can be classified as generic or as specific in terms of their type. Generic servers are provided by Fire community members. So these use the full standard, and they have set up generic servers, which are almost in full compliance with the specification, and these servers are made available for downloading, and they can be used to conduct tests to see how they work. And if you're a member of the community, you can also interact with those generic servers and help to improve them and update them and expand their capability. So these servers may be downloaded. That is how they can be accessed. And then you would have to perform some configuration tasks for specific servers. They are focused on a solution, and they usually involve a fee. Not in all cases, but that is pretty much the pattern. The developer has to implement a number of features in order to obtain the desired solution. In the Fire environment, we see free servers like Happy Fire. You can download it for free. We'll see that a bit later. And then there's a for fee version, which is a Smile CDR. It's also a Happy server, but it's more robust. It has configured features. You can use a panel to configure the server so that it can activate or deactivate certain behaviors, or so that it can be made more flexible to accommodate specific situations. So you have others that are for fee. IBM has one. Microsoft also has a Fire server. There's a Dutch version from the Firelli firm. I don't recall the exact name right now, but it is another option. And there are others that are not listed here. They are from non-English speaking countries, but they have set up solutions, and those solutions are also available. Fire servers, at least the one we're going to be installing, are flexible. They can adapt to solutions depending on the layers and the iterations of the applications. They can be installed as a facade, as a layer, so the client would send Fire requirements to a point of origin, and that origin is fully under the standard. It receives the requests, and the system then delivers Fire operations. But it can also be found as an intermediate point if the client and the origin are not communicating directly. Because of their interactive channels, they may not be fully interactive. For example, there could be a difference in the language used, so that server, that intermediate server, can store the request information and allow the client to query. Then the last case is where it is a client-based facade. The requests are converted. And as I was saying before, there are a fair number of server implementations. in the environment. You can see them here. There's one that is on Pascal. Then Firelli has a .NET servers. HappyFire is fully Java-based. And we'll explain why this is so and what flexibility it affords. We have Smile CDR, which is for which there is a fee. Spark C, which is another one, IBM, then Cyro, which is R4 based. This is Australian. As I was saying, there's also cloud services. Microsoft has launched some through an Azure API, and there's also the Cloud Healthcare API. Now, where can you find this information? You may find this information on the specifications page. There's a link to public servers. You can find a list there. And in addition to that, they provide public test servers. So if you don't want or don't know how to install a server, you can access one of these servers fairly quickly. They are online and you can upload resources and interact with them at will. So you doesn't require any further development. And they're quite flexible. Now, how to deploy a Fire server? The server we're going to be working with is a HappyFire server. What you see here on the screen is the Happy web page. What's important about this is that it's a server which has been developed significantly in recent years. It has a community which supports it. I and my colleagues have also contributed with some changes or suggestions, so I would say that it's quite robust. This lists the server, what it's about, its components. It is a Java-based server. And with the repositories, you can download the code. If you work with Java and you cannot use the code, you can make adjustments to the server. There's some projects which gives access to the server libraries, and this information can be used to use the server, but we're going to start with the HappyFire starter repository. It has a generic database. It has an indexed engine, so you download the code, you install it on your device, and in 5 minutes, you can have it up and running and ready to operate. As I was saying, behind it, there's a very strong community. It's Chat and Fire, which is based on a tool called FIAP. You can see the different channels. There's a channel for implementers, which answers implementation questions. So it's not just for HappyFire. This is for the specification in general. You can also ask specific questions. To install HappyFire, you have a number of options. We're going to look at the simplest one today. It's Docker Compose, which uses containers. But if you need to make other changes, you can download the code, you compile it using Maven, and can then deploy it fairly easily. Then there's others which are similar to Maven. So these are the options you have for installation. We also set up an installation guide as part of the project. This is for the HL7 project. Actually, for the DDCC project, here's the link. There's also a Confluence page where you will find very simple instructions as to how to deploy a server using Docker Compose. You have a list of the requirements, also the structure of the container file, and also how to start up the server. And there's also a self-help as to how to do this using Maven. But that's not within the scope of this presentation. We're going to focus on Docker. So before you do anything, you need to make sure that your operating system has Docker, and especially it has the Docker Compose feature that's installed. Here are the links for installing. And as far as your device, if you want to test this on your local computer is fine. You need to have 2 cores. And you could also do it with 4 gigabytes of RAM. But I would really recommend having 4 cores and a minimum of 8 gigabytes of RAM. The Docker Compose, and I'll show you the files later, but you also need to have a file where you store the environment variables. And we tend to store this outside of the container file. It's a good practice. And then you have the container configuration file, which is a YAM file. So the environment variables can then communicate with the application.yaml. And this is where you can introduce changes so that the server can enable or disable different components. We're going to see this in a bit in practice, so I'll explain it then. So let's do it. I have a terminal here with a Linux. Let me make sure that there's nothing in here. So we're going to create a file to environment variables and all right. The environment variable file has a Postgres user and then the password, so only 2 variables. I'm going to record this. And that's the environment file. And here's the Docker Compose instructions. If you have questions, please ask me, but basically it's a container. You have it here. It's a database support. Then the environment variables that are in the environment file, .env file. And then here you have the Fire server. This is a 6.10 version. And the environment variables you have here communicate with the application YAML file in the happy file, in the happy Fire. So this is the database, the port, the name, who we're interacting with. You have the user and password credentials. And then you also have the dialect, Postgres. And then you also have some other information like maximum number of pages, etc. So I take this content and I put it in a Docker compose.yml file. So here it is. Record this. Okay, with that command, I make sure that the Docker Compose file has been properly configured. We're going to launch it. So the instruction is Docker Compose up, and D is that it's going to be done in detached mode. The first thing it's going to do, first thing the system is going to do is download the network images. So the first time you deploy, it's going to take a bit of time to download the information in the container. And once that information is downloaded, it's going to be recorded in the memory. Okay, we have deployed the containers. So the command is docker ps. Here it is. So we have Happy Fire here. And the data engine behind it, that's Postgres. So how do we confirm that the server is running? You can do it with a curl. Get HTTP local host. I'm using the same device, so there's no problem with that. And what I'm going to do is go to the 8080 Fire. What's the server address? I have a rejected action. Let me see what happened. So it's 8081 actually.
HTTP localhost 8081 Fire. Here we have 81 and 80. They're both open. Very well then. I think the server was being deployed for the first time. But the way you do this, if you're inside the server already, you can point toward the base direction of the Fire server, and you will get the JSON response. The message in this case is this one right here, the URL of Fire server, that's the base. And with this, you can say that the server is operational. If you're far from your device, your computer, you can do it with a graphic procedure. I know this by heart. It is HTTP 198.81. So here I just put the information. What will be the triggering element is the graphic interface of the Fire server. Here you have the resources of the actual specification. By default, it picks them all up to conduct configurations. If you have a project that only uses 3 resources or 2 more, you can omit the rest and you can just work with those specific 3 that you chose. So let us open up the page, and this is the base address, which is the URL base. this address is as local host. But having this address right here, you can interact with the Fire server. So I can take this and I can move it on. Like here. Here you have it, HTTP 192. In this case, I'm going to be asking what is the capability of the servers. This is the URL base or basic URL. Then we have the metadata operation. This is not the resource, it is an actual operation. Very well then, so here now you can see just by reading this information, it retrieves a capability statement resource, which describes the operational capabilities of such servers. It's based on Happy Fire 6.1.0, and that the implementation in this instance responds to an R4 specification in the server, version 4.0.1 of the specification, and the format that it takes to interact with, maybe through Fire or JSON or the turtle, X-turtle, which I don't use very much, but you can interact with these three standards, including JSON, in order to build up your resources. Here you have the remaining capabilities of the server for each one of the resources. Here you can see the actual interactive capabilities that you have. I can update, look up, have historical versions, previous versions, to read the resources or to make patch over them, and a whole series of other operations, such as the ones that I show here, create, among others. So if you want to restrict the actual development or deployment of the server with regard to certain operations, this can be done and ought to be reflected right here in this resource. So here you have a very simple example for the case of a patient. It is carried out with the base of the URL server base, then the resource, and then I add the UP1. And what the server is showing me is an operational outcome resource, which indicates that resource 1 does not exist. And this is because the server is empty. It is a post operation. Let me give you an example of a patient here. Let me bring it up. I have a JSON file right here where I have a patient example, an example of a patient. And when I send it, and then when it's stored in the server, the answer postman gives me a 201 status that tells me that the patient has now been created, and it is assigned ID1 in order to recognize this resource in the server. So if I move back to the previous question, where it told me that it did not find it, it did not know of this resource because it was non-existent. Here, otherwise, it does find it. Likewise, and through the verb put, which is one of the glue verbs in the spec, I can make changes. Here, I give a second name to that patient, and I do the update. This is somewhat slow. 180.81, 128.800. So here you see that the resource continued to be ID1, but now it has a new version, which is version number 2, because the resource has changed its status. I can read out again the resource as it was before, and I point to version 1 of the resource, because version 2 already has changes made to it. And finally, I can have a draft of the resource. This we do with the server plus the resource. And here I indicate the ID of the resource, in this case, ID1. We're working between 8081, so I'm going to make that necessary change. We move down here, we have the outcome, and here we see the information as to how this step went. This was erased in 65 milliseconds. It was deleted. So this is the way in which you work with a server. Moving back, there are certain commands which might be useful as well. The UPS, APPS, a LACPASS, and this is an up to 9 minutes in the status. And I can stop it with the Docker stop, be it by using the name of the container, no, it is not the name of the container. Rather, I can do it with the IP. Ah, here it is. Here's the happy fire. And with this, I can stop the containers. If I must make any changes, I can upload it once again. And with the command Docker start, I can bring it, I can upload it to the server. Happy Postgres, happy fire. And here you have the containers once again, which are operational. And to download the full container, I can use the same Docker compose that I used initially, but in this case, we put down, which brings down indeed the server, and it downloads the database. Very well, so moving back to my presentation, I believe I don't have any other topics to take up today. I had already explained, oh yes, I remember now. This is something I already explained, but it's part of the presentation, and it's also in the instructions. So if the server is actually working, you can use a curl, and this goes to the Fire server. And then you should have a message like the one here on the right. Or else if you don't have any curl expertise, you can do it with the interface graphic interface by using the port. And thus you have access to the information. Well, without further ado, without nothing much to say, if you have any comments or questions, you're welcome. And thank you so very much for the time you've given me. Thank you, Marcelo. In the chat, there are a couple of questions, a couple of interactions. Let me look at it. Let me go to the beginning. There's the guide. The link has already been included. It says greetings to all of the servers you mentioned, which would have sufficient performance in order to give support to the operations of an entire country and generate resources of IBS using the resources of 35,000 different systems. Okay. Later on, the same question goes on, and there's a whole conversation with Alejandro. So it might be good to discuss, because I don't know if you all saw or had a chance to read it. Yes, I can leave it on the screen so that you can follow it. But what I see is that there's been a discussion of the performance of the servers vis-a-vis humongous volume of information. Perhaps I am not the best indicated person to speak about internal architecture. Alejandro has greater knowledge about the yields or the performance and strengths of each and every server. According to my knowledge, ICR is one of the possible alternatives, which is solid to conduct this type of implementation, as well as that of the Dutch. Yes, it might be important to say that this is not just a system, but rather the architecture in accordance to whatever is defined as a project, which truly responds to the question that had been made by Carlos. I don't know if it was clear in the response or if you were able to read in the chat the answer we gave to a similar question. I don't know if there's a new question or the answer given does not apply, but what we can indeed say is that on the score of these are all, some of them are payment fee tools, others are free, and we have to decide whether you get a free or alternative to be able to configure having an application with all the necessary mechanisms in order to give support to a very high demand level, to correct mistakes and all the other non-functional elements which are required nowadays. There are other alternatives too, which are in the cloud. Microsoft also allows to provide support to that type of operation, be it by transactions or charging according to space and so on and so forth. But there are other alternatives. Payment alternatives have the support of the company or the owners of such brand or such application, and they provide the necessary assistance to the technical team so that the implementers may be able to adequately configure all the elements. It's a huge planet, whole deal of things. It depends on the solutions and the actual specific problems that you may wish to tackle by way of a Fire server. What they all do right there is they store resources. They allow for consultation. They also allow for certain types of searches, and there are certain specificities for each one of the solutions. There was also a question about the supported database. For example, this is the case of Happy Fire, which has the LRM motor drive, which supports several types of data. So there are several alternatives, and these are the ones that were mentioned right here because there are alternatives in other languages as well. So I think Marcelo here presented us with the link, including all of the Fire servers. We would have to look at it and see which is the alternative that better suits the development team if they want to find a solution through Fire. What we can indeed say is that there are many of these libraries with much information and for all people. There are also PHP-E tool, what we were looking at in Java, in C, and so on and so forth. Yes. Besides the actual installation that we looked at today with Happy Fire, you're not tied to any certain database. In the configuration file, you can just change the dialect of the database, and you can eventually use an USQL or any other that gives support, that the supporter supports. So see which other dialects can be supported, and you can make this change as I'm showing you right now on the screen. Here you have the values that have to be changed. The data source. No, you're not sharing your screen with us yet. if I could share with you here in the instructions under the Docker Compose section right here. This is the Fire container. There are certain environment variables. The first deal with the database that you're going to be using. JC, BBC, Postgres. You can change it for SQL or for Molsat. Here you have the credentials to have access to the database. And what we must change here is the class of the driver, and something which is important is the dialect. Dialect being used because the server behind it has a JPA model underlying it. So you must adjust it to that dialect so that the JPA may recognize and truly understand that it's speaking with a database which is different. So by making all these changes, there should be no problem whatsoever. You launch the Docker again. You have the data in that container, which is not being used any longer, but you can use an USQL container or a USQL database elsewhere. And all you have to do is show database and the port.
And you don't have to use Docker. It's not mandatory. You can use other applications to set up. That's if you have issues with Docker or don't understand it. You could also use a Tomcat or other type of server. It's an option. But what I should add is the tool environment required to set up a Fire server is available. So you just need to have a team that is able to set it up so that it can provide a solution or can be used for testing. It seems that we have no other questions. Someone is asking, how will the recording be shared? We'll be sending you a link. It seems that we have no more technical questions, so I thank you for your time. Oh, there's one more. It's about installation testing. The question is about installation and validation models. I don't understand the question, Jose Luis. Hello, good afternoon. You've given us the steps, and once we've installed the components, how do we validate the installation? How can we test? How do we know that we're ready to use the Fire resources? Okay, I get it now. I showed you some examples how you can perform some operations. It's not in the installation guide, but we can provide it so that you can use the connection and interact with the server. Okay, thank you. So we will add those to the guide. There are some people who are more familiar with Fire and don't have all that many issues adapting, but for others, if you're just learning about this, you're right. It would be useful to have that information so that you can confirm that the server is up and running. We've noted your comment. Thank you, Marcelo. Thank you to all those of you who have participated and asked questions. I, to Marcelo, would like to suggest that in the installation guide, you include how to download the Postman examples. That installation is agnostic. It's a basic Happy Fire survey that supports the standard. And the exercises are also along the same lines. So you're invited to join us next Thursday, same time. We are going to be looking into the transactions supported by the DDCC documentation, or the documentation on which DDCC is based. That's all for now. Thank you very much for coming to this session, and have a very good afternoon.